This is Alex. I'll be explaining question 2 in quiz 4. So in problem A, we're asked to find the sound speed at 27 degrees Celsius. So we can use this formula to find that the sound speed at 27 degrees Celsius is equal to 347.7 meters per second. So in B, we asked to determine what type of pipe it is. It's an open pipe because the argument here is if it's closed, there wouldn't be a second or fourth harmonic. Well, because of the formula for open-closed pipe is Fn equals n times v over 4l, and n can only be odd integers 1, 3, 5, etc. So according to this graph here, there are second and fourth harmonic, so it wouldn't have been an open closed pipe. So in C, it's asking us to answer for the fundamental frequency, which is 1000 Hertz, and D, it's the first overtone, which is 1004 Hertz. Now, onto the second page. In E, we're given a formula, this formula, and then we're asked to find the actual length, the actual pipe length of in this formula, which is L on the right side of the equation. What we don't know now is the L sub c. So that's easy. We can use this equation to find L sub c is exactly equal to L right here at the bottom of the fraction. So using this formula, we can find L sub c through a little bit of manipulation. Is 0.173 meters. However, if we plug it back into this equation, we can solve for the only unknown left, which is the actual length of the pipe, is 0.154 meters. Now, in F, we ask that without changing the length of a pipe, is there a simple way to change the fundamental frequency by a factor of either 2 or 1/2? Excuse me here. Sorry. So the simplest way would be closing one end because of the formula here. So to change it from an open pipe to open closed pipe, it would be it'd be multiplied by a factor of 1/2, as you can see here. Well, the second part of the question is to find the two lowest resonant frequencies. So to find frequencies, we can use this formula, but we need to know the new lambda after the change. So it would just be multiplying by a factor of well, 1/4 now. Sorry, excuse me, multiplied by a factor of 1/2, and then it becomes 1/4 times lambda, and that's the new lambda length, wavelength. Now we know these two. We can find the frequency. Well, it turns out the first fundamental frequency, excuse me, is now 563 Hertz. And the third harmonic would be 1690 Hertz.